Today we will discuss about a paper, research paper that is a case study for analyzing power generation from waste. So different type of waste, different or I should say four type of waste are being studied here, and the scope for generating power using that waste. And the study is including a case study of a uh, town, Faridabad. Okay, that is in Delhi NCR in Haryana. Okay, so first of all, the abstract. So the increasing waste that is being that is becoming a challenge to handle it, and mismanagement in handling and treating of the waste that is causing environmental issues as well. So on the other hand, the requirement for electricity that is also increasing with the increase of population and the increase in economy, and the more load that is being put on the fossil fuels, and their stocks are also extinguishing. Okay, so it is becoming extinct. So in that case, with both of these problems, that is the waste management problem as well as the power generation problem, both of them can be solved if power generation is done using waste as a resource. So four type of waste include municipal solid waste, animal waste, agriculture waste, and sewage sludge. So all four of them are being studied in detail, and the scope for generating electricity in large industrial towns. So Faridabad is such type of town. So some brief detailing about the district Faridabad. So it is spread in 741 square kilometer area in city of Delhi. So it is having 144 villages and population of nearly 18 lakh 9,733. So electricity demand that is expected to reach 69,613 lakh unit in the year 2024. Further, it can increase to 90,497 lakh units in 2027. Further, in 2030, it is expected to increase to 1,17,646 lakh units. So in this case, we need some source or the fuel which can be used for generating power. So as on March 22. So this data is in the paper that is until 31st March of 2022, and still into 2024 as well. The major of the power generation that is through the fossil fuel, that is coal, specifically that is coal. Okay, another thing is that the cost of transportation. Okay, if any type of fuel or raw material that is being transported, then the cost of transportation that is being beared, which makes the power costly. Okay, so the railways is there, waterway is there, and roads on road that is also the mode of transportation. So here we can see that on the highways or on the on road the transportation that is 2.5 approximate cost per kilometer. Then 2.5 rupees, the amount is in rupees. And then in railway, using railway as a mode of transportation for the same distance, the cost is reduced by to 1.36 rupees per kilometer. And if we are transporting it using waterways, then the cost is further reduced to 1.06. So this gives us an idea that transportation using water or waterways, like a through river, we can say. Okay, so that is the cheapest mode of transport. Okay, so here in case of municipal solid waste, the power that we are generating that is very near to where the waste is being produced, and right where the power is being consumed. Okay, so the transportation that is not needed. Even transportation of electricity that also requires a huge transmission network, and a lot of power that is also being lost in transmission. Okay, so that is also a type of loss there in our power sector. So this type of losses and the cost associated with them, they are recovered using this type of model. We can say this is the distributed generation model where we are generating the power near the load center or where it is being consumed. Now, considering each one of the sources of the four waste sources one by one. So first one is from municipal solid waste. So as per the data available, Faridabad is generating this data is available from the municipal corporation of Gurugram. So Faridabad is generating 716 metric tons of municipal solid waste. Okay, then there is a Bandwadi landfill site that is spread in approximately 30.5 acres. And the two districts in Haryana, Faridabad and Gurugram, both of them are using this Bandwadi landfill site. So dump site is filled beyond its limit. And another dump site is being proposed in Pali, but it is facing some legal objections from the residents nearby. So a 15 megawatt waste to energy plant is set up there. That is being utilizing the waste. It is actually waste to energy plant, so it is using the incineration or similar to a thermal power plant. So it is using incineration of waste for producing electricity, the power. Okay, now considering the constitution of municipal solid waste, approximately 40 to 45% of this is organic matter, 20 to 30% is inert matter, and the rest is recyclable matter. So the maximum utilization of MSW depend upon the efficient collection of waste. Okay, so the collection of waste that should be very efficient. Okay, for residential areas and housing societies, the door-to-door collection is a very good option. So here in the districts in Faridabad, it is industrial and a huge population is living in residential apartments, housing societies. So there the waste collection that is easy. So other unregularized areas, the waste is thrown in any open place. So that is need to be collected first. After that, the waste is to be segregated. The recyclable items, they can be separated and sent for reuse. Inert matter, okay, that could be sand, mud, construction, demolition waste. They can be, after segregation, they can further be processed and reused. So the organic matter present in MSW, the municipal solid waste, can be used for generating electricity. So here the point is to minimize, or we can say we should efficiently reutilize the waste. We can make we call it for a circular economy, that whatever is been taken is returned back in the most efficient way. Okay, so MSW generated per person for the duration of 2022 to 2035, that is as per a survey, it is 0.4 kg per person, or 400 gram of waste is generated by one person. Okay, so here the equation shows the MSW generated in metric tons is equal to population multiplied by per person MSW generated in one day multiplied by the number of days in a year, that is 365 divided by 1000. So yearly this much amount of MSW is generated. Okay, so for the population living in Faridabad, so this is 18,09,733. This amount is approximately 20. This is 2,64,221 metric ton. Okay, so here, if the collection that is efficient, okay, then we can consider 90 to 100% of the waste that is being collected. So it is approximately 644 to 716 metric ton. Okay, then the useful matter. So considering 45% of that is being the organic matter, okay, this gives 289 to 322 metric ton of raw fuel for obtaining energy. So two methods considering here the already existing waste to energy plant. That is one method, and anaerobic digestion for producing biogas. So here the power plant is already running there, but here this study, it is being considered that the two methods are available. How much energy we can produce for consuming whole of the available organic waste only, not whole of the municipal solid waste, only the organic matter. Okay, after that, because the recyclable and inert metal are already being reused. Okay, so as to make a circular economy, or we can say not to create a mismanagement between the ecology. Okay, so in incineration in waste to energy plant, the first method, so it is pre-processed and fed to the boiler, steam is produced. So direct combustion of MSW that causes emissions, carbon emissions. So for this carbon capture or carbon capture and utilization techniques, they are needed so that those emissions are not made into the environment directly. Okay, so this is one of the measure, although it is good for the environment, but it may also increase the cost of the power generation. Further, the collected carbon content that can be used in other industries like the oil gas recovery, chemical production, mineralization, desalination, and water production, and all that similar type of applications. So another study. Okay, references are given in the end. I will share the link. Okay, energy generated from waste energy plant, that is shown in this equation. So it is equal to the useful waste in metric ton into gross calorific value into 1000 divided by the heat rate. So putting the values, gross calorific value of 1319 calories per kilogram, heat rate as 3500 kilocalories per kilowatt hour, and the available useful MSW, that will be 108 to 121 megawatt of hour of electricity. Okay, so the amount of municipal solid waste can produce this much amount of electricity. So that is a good amount. Okay, further, in one day, this data that is being produced 108 to 121 megawatt hour of electricity in one day. Okay, now coming to the anaerobic digestion of municipal solid waste. So another method for treatment of municipal solid waste. So anaerobic digestion consists of action of microorganisms on organic matter. So that could be the food waste, garden waste, animal waste, okay, similar type of organic matters, biodegradable matter. Okay, in the absence of oxygen, this method takes place, anaerobic digestion, and biogas is produced. So main constituent of biogas, that is methane, about 50 to 75% of methane. So the calorific value of this is 36 megajoule per cubic meter. So this can be used as a fuel. Okay, something similar to that of a natural gas. That is also having a main constituent is methane, but the methane content is high in natural gas. Okay, so this biogas can be used as a fuel in boilers to produce steam. Also, it can be used to power biogas engine. So these engines can be coupled with the generators for electricity generation. So these type of methods I have discussed here in my previous these videos which I have shared in the same playlist. So here is a table, and it indicates that how much amount of biogas per biogas in terms of normal cubic meters per metric ton of organic matter or the biodegradable matter which is being used for anaerobic digestion. So here animal waste is there, then agriculture or food waste is also there. So here we can also take an idea that the animal waste that is already digested, so the amount of biogas produced, that is less as compared with the food plant waste, agriculture waste. So they are producing a much higher amount of biogas. Okay, the methane content in the gas depends upon the type of the substrate used. So approximately we are taking the value 62.5%. Okay, when we are using animal waste as substrate, it could be lesser when using food waste. So some other factors like the carbon to nitrogen ratio in animal waste, that is less. For efficient anaerobic digestion process, the C2N, that is the carbon to nitrogen ratio, should be 20:1 to 30:1. That has to be increased. So agriculture waste are having high carbon content. Animal waste are having low nitrogen content. Okay, so a combination of both of these substrates, they are being researched upon, and it is found that they are producing a more amount of biogas by co-digestion, adding animal and plant waste. Okay, so here in the table 2, the technologies for the technologies basically they are thermal technologies for generating power from biogas. So turbine and micro turbine, the flow, then amount of power generated, that is being indicated here. So approximately 4 cubic meter of biogas generates 5 kilowatt hour of electricity. So using this data, we are getting 43 to 70 megawatt hour electric energy in one day. Okay, yes, so here the amount of energy or the electricity generated, that is less as compared with the direct combustion in waste to energy plants. Okay, but it is having some other advantages like the residue or the digested slurry which is obtained after anaerobic digestion, that can be utilized, further utilized as the fertilizers. So the nutrients can be supplied back to the ground, to the earth, as if they are used in the agriculture purpose for manure for fertilizers. Now considering another type of waste, that is the animal waste. So this is the 20th livestock census in 2019. So the population of different type of animal that is being indicated here: cattle, buffalo, pig, sheep, goat, poultry. So amount of biomass available from different birds depend upon the feed, the age. Okay, so it is indicated here in the table number 4. So cattle and buffalo, they are producing 10 to 20. kg of this biomass. Okay, then pig, then sheep, goat, then poultry. Okay, now coming here to the next column. So we are considering the average to be 15 kg per day. Okay, so it gives 23,50,57,565 kilogram. Okay, then further from the pig, 6,428, then sheep and goat, 21,022 kilogram. Further, the poultry. Okay, so anaerobic digestion of animal waste, that is giving the biomass. So further the factors, they are being taken care of. The pH values, their temperature is approximately less than 40, more than 30. The temperature is giving the more output. Okay, further the approximate biogas yield from animal waste, that is 63.8 cubic meter per ton of animal waste. Poultry bird, that is higher, 97.8 cubic meter per ton. And then collection efficiency, that is high for this case because the cattle, buffalo, they are being they are available in farm. So their farm the very high efficiency poultry farm, from there we can very efficiently collect the animal waste. Okay, so about 1,52,717 cubic meter of biogas that can be generated from efficiently collecting the animal waste in the district Faridabad. And in one day, we can get 190.9 megawatt hour of electrical energy. Next type of waste we are considering, that is the agriculture waste or the agriculture residue. So one, stubble burning is a very big issue which we are facing from this uh, agriculture waste. So in Faridabad, this 215 hectare land is used for cultivation of rice in the Kharif season and wheat in Rabi season. So rice is cultivated in 27.4 hectares and wheat in 104.8 hectares out of this 250 area. Okay, so the wheat crop residue left can be used in animal fodder, but rice crop residue, that is not used as animal fodder. So to get rid of this residue, usually stubble is being burned in the farmlands. Yeah, although it is much reduced in the current years. So this is one method for obtaining energy from the animal waste. So from 27.4 hectares of area, which is being used for cultivation of rice or paddy. So in from that, approximately 130 metric ton of waste is available, which can be used as a fuel in waste to energy. Yes, direct incineration like the municipal solid waste, or by using anaerobic digestion, and we can produce biogas. So when used in WT, waste to energy power plant, 49 megawatt hour of electricity that can be generated, and using this agriculture waste as feedstock for producing biogas, 20 megawatt hour of electricity that can be produced. Okay, so here in the anaerobic digestion, we are getting the manure as well. Okay, now the last type of waste which we are considering here, that is the sewage sludge. So wastewater needs to be treated, okay, before being discharged into water bodies. Okay, otherwise the water body, they will be contaminated. So on in the treatment, sewage sludge is left from the wastewater. So the composition of sewage sludge is highly variable, depend on the many factors. On the season, it depends that technology applied in the sewage treatment plant, that also affects the composition of the sewage sludge. Okay, on average, sewage sludge contains 50 to 70% organic matter, 30 to 50% mineral components, and 3 to 4% nitrogen, 0.5 to 2.5 phosphorus. Okay, some other nutrients, they're also included in that. So wastewater can be considered as a, first of all, the source of water after treatment, then energy, then organic metal and other resources. Okay, so this type of sewage sludge left, a lesser amount of lignin and cellulose are present in that. So decomposition is also easy. This is in contrast with the organic matter in the like in the municipal solid waste. So treated wastewater find application in irrigation, toilet flushing, groundwater replenishing, and it can be further purified and used for household and industrial purposes. So here in the case of Hyderabad, it is on the banks of river. Okay, so the wastewater collected, that is from the sewage system, it covers 638 kilometers. So on-site containment system is built with septic and fully lined tanks. So these are connected with a central sewage system. 11 intermediate sewage pumping stations are there and 3 main pumping stations with 3 STP in the city, having an installed treatment capacity of 140 million liters per day. Okay, so the maximum. So about 40% of wastewater is lost in leakage from sewer lines. So that is the one thing is we have to reduce. And now the technique of anaerobic digestion of sewage sludge that includes that produces biogas as a digested sludge and can be used as a manure. Okay, so biogas we are getting and manure we are getting. So here 225 kilogram per 10 to 10 to the power 6. Okay, so this much amount of sludge is available. Okay, so totally this can give 26,325 kilogram of sewage sludge in one day. And on anaerobic digestion of this, we can get 15,795 cubic meter of biogas, which can be used for producing 19.7 megawatt hour of electricity in one day. So there's a good amount of electricity which we are getting. Also, where we are getting and the fertilizer. Okay, the digested sludge that you can use as fertilizer as well. Okay, now another source which we can get another fuel, we can say hydrogen. That can also be obtained from biogas and electricity generation from hydrogen. Okay, so hydrogen from biogas. So one of the very commonly used technique that is a steam methane reformation. So it takes place at high temperature from 700 to 1100 degrees Celsius. So the equation that takes place here, so the methane it is there CH4, then using steam H2O, it will give CO plus 3H2. Okay, then another reaction for increasing the hydrogen production between carbon monoxide and water taking place at a lower temperature of 360 degrees Celsius. That is given as CO plus H2O. That will give CO2 plus H2. So hydrogen here we are getting as well. So this hydrogen that can be used as a fuel in fuel cell to produce electricity. So hydrogen fuel cell. So some type of fuel cells which are available, well, not widely available. Okay, but in the future they will be available here and will be commonly used for power generations in the automobile sector as well. Okay, so alkaline fuel cell, proton exchange membrane fuel cell, phosphoric acid fuel cell, molten carbon fuel cell, solid oxide fuel cell. So out of these are low temperature fuel cell like the alkaline and the proton exchange membrane. They can be used. They use only pure hydrogen. Okay, for high temperature fuel cell like the solid oxide fuel cell, direct the biogas can also be used as a fuel. So all of them operate on the same basic principle. So hydrogen is supplied there to the anode and oxygen to the cathode, and both of them combine and electricity is produced and water is left as a byproduct. So it is totally environment friendly method using fuel cell for producing electricity. So fuel cell they find application in electronics, housing, power, then power plants, electric vehicle, and military applications as well. The different type of fuel cell operate on different temperature ranging from 65 degrees Celsius to 1000 degrees Celsius. So low temperature as well, high temperature as well. Okay, so that I've already discussed, so I can move ahead with that. The final conclusion here, so different type of waste, okay, they can be used as a resources for obtaining energy. So the process for obtaining energy is highly dependent on the efficiency of waste collection. So first we have to increase the waste collection, like the all of the municipal solid waste, we have to collect leakage in the sewerage lines that has to be minimized. Okay, so all of the waste when collected, that gives the maximum returns. So low manpower cost is available. So this is another positive point for the feasibility, economic feasibility of such system. Close monitoring of the entire process of waste management and power generation, that is also needed so as to maximize the advantages. Segregation of waste, that is needed. Each type of waste has to be treated using the suitable technology available, maybe anaerobic digestion for the environmental point of view, from the circular economy point of view. So all of this together, these techniques, they are all of these four type of waste along with suitable techniques which we have just studied. So it can fulfill approximately 2% of Faridabad's electricity requirement. So byproduct left after the anaerobic digestion, they are also suitable for agriculture purposes as manure. So that also adds to the economic value. And the process of anaerobic digestion, all of the nutrients, they are returned to the earth, recyclable material, they are also being recycled. So that is making a circular economy. So references are here. So we can go through it. I will be sharing the link in the description as well.